Hi there, welcome back to another video. In this video we will be talking about horizontal shrinks and stretches of linear functions. So horizontal shrinks and stretches are another set of transformations that we can do on linear functions. And as a reminder, we do these transformations in order to get from one parent function, f of x equals x, to all the different linear functions. And again, as a reminder, the parent function doesn't have to be a linear function. We can do these same transformations to other types of functions as well. So what are horizontal stretches and shrinks? Stretches and shrinks in the horizontal direction happen when we multiply the x-coordinate, so we're talking about the horizontal coordinate, which is the x-coordinate, by a number a. So what we're doing is we're going from, say, f of x equals x to h of x equals a times x. So that's what I mean when we multiply by a number. We're going to multiply not by a variable, but a number a. Now, the interesting thing is that if we use an a that is larger than 1, we will get what we call a shrink. And if we use an a that is between 0 and 1, like a fraction, we will get a stretch. And I will show these in more detail in the two example graphs below. So let's look at this first one on the left. We're looking at a shrink. Okay, so this is a shrink. Why is it called a shrink? Well, if you look at our original graph here, the f of x is x plus 2. When we made our transformation to h of x equals 2x plus 2, we see that the graph shrinks towards the 0 of the x. What is the 0 of the x? It's the y-axis, or the f of x axis here. So we call this a shrink. It's basically just a name. If it doesn't really look like a shrink, it doesn't really matter. The point is that we have an intercept here with the y-axis. And what we're doing is, by multiplying our x by a number, we are basically sort of spinning this, this graph towards the y-axis or away from the x-axis, and that's why we call it a shrink. Now, we've sort of seen something like this when we looked at the reflections as well. In that case, we were using a equals -1, so we were going from x to negative x. But in this case, and I don't want to emphasize that too much, we can look at any a. And when we're looking at a shrink, we're looking at a greater than 1. So let's look at how this happens. Let's actually take various points here and see what happens. So for instance, we have the point x equals 2 here. And if we take the rise up on the red, our value here is 4. And indeed, f of 2 is 2 plus 2 equals 4. Now, what happens if we multiply our x by 2, like here, and then add the 2? So we're getting 2 times 2 is 4, plus 2. We will rise all the way up to 6, right? So you can see that this transformation will shift the same x at the same x to a higher y value. Let's look at this point here. Okay, we have x equals -3. In this case, we're looking in our red curve, our original curve, we're looking at the value -1, while in our blue value, we are looking at -4. So here again, we are spinning or moving away from the x-axis, so we call this a shrink. Now, the opposite happens when we look at what we call a stretch, in the case where a is larger than 0 but less than 1. So it's a fraction. And in this example here, I took a equals a half, or 0.5. So what happens here? Let's look at the same points. Let's look at x equals 2. Same points we looked at for the other example. So on our red curve, we have y equals 4, just like previously. But on our green curve, we're looking at y equals 3. Why is that? Well, we take a half of 2, right? We're taking x times a half, which is 1, plus 2, and that equals 3. So we've moved downwards, and basically, again, our intercept will not change, but because at our intercept x equals 0, right? If I didn't make that clear, that should be clear. The reason the intercept is not changing is that 0 times any a is basically equal to 0. But on any other point, what we're doing is we're moving our graph, spinning it lower down, so we look like we're stretching along the x-axis. So stretching along x-axis. While here, we were shrinking along the x-axis. Now, if you've had a chance to look at the vertical stretches and shrinks, you'll see that they're essentially the opposite. So if you haven't checked out that video, check it out, because it shows how basically a vertical shrink is equivalent to a horizontal stretch, and a vertical stretch is equivalent to a horizontal shrink. It's not exactly equivalent. We would have to also do a translation in some cases, but it's equivalent in that it is spinning the graph in the same direction. So this was a review of horizontal shrinks and stretches. And again, if you want a shrink, you have to take a greater than 1. If you're looking for a stretch, you take a as a fraction. If you take a negative a, you're also going to get a reflection.